C-Ram and Advanced Automated Point Defense Gatling Gun. Indirect fire from mortar, missiles, and artillery shells is a very serious concern for armed forces in a battle. But thanks to point defense systems like the C-Ram, indirect fire of this nature may have met its match. The C-Ram, standing for counter-rocket, artillery, and mortar, is a land-based phalanx weapon system with the capability of integration with other protection sensors and systems. The system is It was designed and manufactured by the General Dynamics Corporation, Pomona Division. It is currently manufactured by Raytheon Company of the United States. Phalanx is a rapid-fire computer-controlled radar and 20mm gun system that automatically acquires, tracks, and destroys enemy threats that have penetrated all other ship defense systems. The Phalanx was designed in the beginning as a ship-based anti-missile system. The Centurion weapon system, developed from the Navy's shipborne Phalanx close-in weapon system CWIS when using already produced systems to defend against indirect fire. CWIS was first developed as an automated weapons defense system in 1973 and incorporated a 20mm M61 Vulcan Gatling gun autocannon used since 1959. The Navy Phalanx system was first appraised as a possible ground-based variant. In 2000, for Phalanx was selected, partly because it could be readily interface with a multitude of sensors and systems designed to provide an overarching protection. The land-based Phalanx weapon system, LPAS system, is mounted on a wheeled platform, provides immediate situational awareness, precision fires, real-time targeting and kill assessment, and mobility for repositioning and deployment. Be mounted on a trailer or the rear side of the Oshkosh truck. In October 2008, Raytheon and Oshkosh unveiled the Mobile Centurion, which mounts the system on a hybrid electric, heavy expanded mobility tactical truck. The first battle-ready C-Ram system was deployed to Iraq in 2010. Trials of this system demonstrated its ability to knock down 70% of indirect fire fired within its area of control. Centurion's C-Ram system is successfully intercepted hundreds of rockets and mortar shells, proving the system's capability as a defensive system. Like its naval counterpart, the Centurion has a Ku-band and TPQ-36 active electronically scanned array radar produced by Raytheon for tracking smaller targets in the air that feature closed-loop spotting technology to automatically acquire and track targets in the microwave range of frequencies between 12 and 18 gigahertz. Similar systems were installed on the Space Shuttle to help identify and track other spacecraft. To protect a given location on the ground, to help provide an overarching protective umbrella, using M61A1 Vulcan cannon. Used to M caliber ammunition can be replaced depending on the mission content, augmented with forward-looking infrared sensors to provide enhanced accuracy and enable fire to constrain shot dispersion patterns. The M61 is an air-cooled, electronically fired Gatling gun. The 6 barrels only need to take turns to fire once during each revolution, can achieve high-speed shooting of up to 100 rounds per second. It was originally produced by General Electric. The Army often temporarily installs the M61 on the M113 armored personnel carrier as a fixed weapon. The M61 family of machine guns has been in military service for more than half a century. It is a system with unquestionable stability. To this end, the U.S. military has developed an improved M61A1 without a belt feed device, including the U.S. Air Force's F-15 and F-16. With the latest F-22 Raptor stealth fighter, M61A1 becomes a fixed equipment of U.S.-made fighter aircraft. This is achieved through the combination of advanced sensors that enable the C-Ram to simultaneously search, track, engage incoming targets and prioritize targets, and make kill assessments. in both daytime and nighttime. C-Ram's Co. Band radar system enables the weapon system to detect potential threats, effectively deal with water targets and low-altitude and slow-speed targets, identify friend and foe to avoid accidentally attacking innocent people. A British Pilkington company was installed on the left side of the radome. HDTI 52F ultra-long wavelength high-resolution infrared thermal imaging system. The HDTI 52F detection frequency is ultra-long wavelength infrared, which is less likely to be reflected by sunlight from the water surface. Attached to the weapon's main antenna, it provides very reliable night and day passive search and tracking, significantly improves the accuracy of the phalanx in tracking small, high-speed targets, and add a manual control station in the situation room, on TPQ-36 short-range firefinder radar, and a lightweight counter-mortar radar to detect and track fired rounds. This hardware is controlled by fire control subsystems. As you might expect, such a sophisticated piece of kit does not come cheap. Each C-Ram system costs somewhere in the range of $10 to $15 million, depending on the final spec of the units purchased. But that's only the cost to initially acquire the technology. With such a massive rate of fire, depending on the number of munitions spent, the typical engagement with a single missile could range between $30,000 to $60,000. Some other estimates put the figure at around $40,000 per missile. This is not only costly from a material point of view, but is also one of the main disadvantages of the system. By spending so much on ammo on a single threat, a limited ammunition supply will theoretically limit the number of threats that the unit can engage at a given time. By some estimates, this might mean that the Centurion C-Ram might have a maximum anti-ram cap of about 5 incoming rounds before needing to be reloaded. The system has some other perceived weaknesses too. For example, it takes about 5 seconds to acquire, lock onto and engage a threat. It also has a fairly short, effective range of between 100 and 1,000 meters. In addition, the caliber of the artillery shells is too small. It is easy to cause the fatal flaw of invalid interception. These weaknesses aside, it has proven to be one of the most effective close-in defense weapons. However, due to the cost of missile procurement, not all countries can afford it, and there is still a need for tasks such as countering suicide assaults. Therefore, many countries still continue to use cannon-type systems.